from graphs to sinusoidal functions. And so this is kind of part 2 of transformations of sines and cosines. When we say, sinusoidal, we really just are referring to either a sine or a cosine. And what we want to be able to do is, it's great to understand transformations. So if someone gives you a function, and then you can go back and kind of graph it out for yourself. But what if someone gave you a graph and you wanted to convert it back in and knew what the actual function was? So that skill is kind of neat because it allows you to kind of really think about, do you understand transformations? What do you do? What are the things that you should think about? So that's what I'm going to do in this video. I'm going to present to you several graphs. Here's one, here is another one, and then here's a third one. And they're just graphs, they're actually restricted. So we're gonna find also the domain and ranges for these. And we're gonna take those graphs and then we're gonna try to figure out what the actual function is. Now, they're all sines and cosines, they're all kind of periodic. So that's the hint that you have. But then I won't say much more, and I'm gonna try to break it down and show you kind of how I think about, transforming from a graph and then getting a function. Now, sines and cosines are related, right? They're basically just a translation by 90 degrees, or pi over 2 if you're thinking about radians. So, so just a kind of a recall, okay? So, if you have a function, let's say sine of x, it basically equals, cosine of x minus 90 degrees. So it's just a shift. Now, if this is, maybe I should write it in both. So I'm gonna, that's, if you're thinking about radians, where your independent variable is in radians, in degrees. But if it's in radians, then it would have been, I guess, just pi over 2, right? So that's one. So you can relate these two back and forth. And of course, if you have your cos function, then this also equals sine. Now, instead of having 90, it's going to be plus 90. So minus 90 is going to be plus 90, or just sine of cos plus pi over 2. So it's just a shift, right, by 90 degrees, either to the right or to the left, and then you obtain the other function. So if you have one, you can always find the other. So that's one thing that we have. And, so just let me show you before I start jumping into, these transformations, because I'm going to use that. I'm going to kind of test you and say, find this one as a sine, find this one as a cos, and then maybe the last one will do both, where we want to take that and write it as a sine and as a cos function. All right. Okay. So again, so notice the x, that's your sine, and if you wanted to just have your cos, right, notice that's just going to be a shift. So that blue, we can just shift over to the right. Now, this scale is in radians because that's what decimals actually does. So because it is in radians, I'm going to just say minus, pi over 2 here, and notice it maps it right on top. All right, so that's what you have there. Now, if it was, if you find your function as a cos, so if you have your cos, which is like this, then all you have to do is, just find your sine. Notice, in this case, we got to put it back, okay? So we got to shift it to the left. So shifting to the left by 90 degrees, or pi over 2, and then that just maps them up on top of each other. So I'm going to use that actually trick, because I'm going to try to take the functions and either use sine or cos, find the functions, and then for the last example, I am going to take and write it as both, as a sine and as a cos. Okay, so let's take a look and see how we can break these things down. So in transformations, so just a little bit of a deja vu. So the initial part of transforming, I talked about in the video, so maybe I'll put it up above there for both sine and cosine. And so just a deja vu, so if you're going to be writing sine, so let's say, here's an example. So 2, let's say sine, all right, and let's say this was 3, x, I don't know, plus, let's say pi, if it's in radians, pi or 180 degrees, okay, and then minus 1. So all of these numbers, right? So this one basically just is the amplitude that we have. This number, so this was like your A. So let me rewrite this A. This would have been sine. I think I used the D. So X. This would have been minus, I think, H. Okay, and then plus K, right? So all of these, so this was your amplitude, so that just would kind of stretch it out to make the amplitude bigger. This 3 just represented either a compression or a stretch in the X, so that just changes your period of the sine function, all right? So your period is basically can be found from here. So your original period that we have is 360 degrees, or if you're writing in radians, it's 2 pi. And now this d, okay, that we have in here, if you divide it, okay, so if you're going to be dividing by d like this, by the magnitude, then that's going to tell you what the new period is. And period we can designate with a capital T. So that's the period. So if this was 3, then what it would mean is that we would have 360 degrees, okay, divided by 3, okay, and that would have been simply, 120 degrees would have been your new period, okay? So it would have kind of compressed it in, okay? So that's, we talked about that in that video. And if it's in radians, if you had it within here, then it would have been 2 pi over 3, which is still 120 degrees. And now the other one, okay, so this one is basically just a shift. Okay, so notice, it's positive here, so that means h is actually going to be negative, right? So it would have been negative pi. So that means that I'm just going to be shifting it, okay, by negative pi or by 180 degrees. So it would have been shifted to the left, okay? And then this last one, this right here, now it is again negative, so you have to be careful. So that would have been a shift downwards, right, by 1. So it would have changed your kind of mid-range point, okay, of your function. So that's kind of a little bit of a deja vu. Now, it's great when these are given to us. So if someone gives us what the function is, but if we have a graph and we have to create this, then we really have to understand how those transformations work, okay? So that's what I'm going to talk about right now. Okay, so here's your first example. Now I am pointing out here, so notice they say that the independent variable is in degrees. So I'm going to keep everything in degrees in here. And now what I'm going to do is, okay, so it looks like this graph is first restricted, right? It doesn't keep going forever. And it is being restricted between 2 different ranges. So I'm going to try to kind of map this out in here. All right, so notice, so it looks like it's being restricted kind of right there, right? So from there, all the way to, it looks like right there. Okay, so that's what we have. So that's going to be our restriction. So first, if I wanted to write down, and I would encourage you to do the same, is maybe construct your domain and then your range for whatever function that you have. So my domain in here, because it is in degrees, so let's take a look in here. Can we kind of deduce? So I'm going to zoom in here. Okay, so what do we have? So I'm going, okay, so notice that it's kind of divided into, so 1, 2, 3, 4, 5, and that's 50 degrees, I guess. Which means that, these represent 10 degrees. That would have been 20 degrees, 30, 40, and 50. Okay, so that's what I have there. Now it stops. Okay, so I'm going to go negative 50, negative 60, negative 70, negative 80, negative 90. All right, so it looks like it's from negative 90. So the domain, so x, okay, and it is in degrees. It's going to be from 90. Now, it's very hard for us to tell if that 90 is included or not. Okay, so I'm going to just say it's kind of like this. Now, if you did that, that's still fine from the information which is given. So let's maybe keep it at that for now. And then it goes all the way to, if I zoom in here, looks 350, looks like it's going to 360. Okay, so it's going to 360. So this is x, okay, sorry, this is minus 90, and it's going to 360, and this is degrees. All right, so that's my domain. My range that I have, okay, let's call it, y. We know that because this is periodic sinusoidal function, it goes from 1, which is on top there, to -5. Okay, so 1 to -5. So -5 to 1. Now we don't really know what that is, if it's, what the unit might be for that y. So I'll just leave it as it is, but that's the range. So that's the first thing that we would want to know. Now, remember that if you know the range, so from your range, you can find the mid point, okay, or the mid range, right? Okay, or kind of the midpoint, which is the middle point, which would separate this, and this is kind of what we need. Maybe what I'll do that, and I mean I can see it. It happens right there. Okay, that's kind of splits it in half. Now the reason why I want that is because then I can easily take out the amplitude. Like I know how big the amplitude is. So notice 1 minus -5, which is going to be 6. 6 divided by 2, is going to be 3. Okay, so my amplitude, it looks like it's going to be 3. And my mid-range, notice it's right there, it's -2, which would have been 1 plus -5. So that's -4 divided by 2 would have been -2. So this is -2. Okay, so that's the mid-range or the midpoint. Okay, so that's what we have, or y is equal to -2 would have been the equation of that axis. My amplitude, I can say is 3. So, that's kind of the height from here to here. And that right away already tells me. So let's say for this first example, we're going to try to find this as a sine function, okay? And it's not unique because a sine function can be always shifted back and forth, right? Because it's periodic, okay? So that's something you have to remember, okay? And then if your teachers kind of mark you incorrectly, be careful, okay? Because, maybe they're just kind of looking at their answer key. Remember, you can always shift a sine function, so it doesn't have a unique representation. It can always be shifted. The amplitude should always be the same, so that's true. The compressions should be the same, right? Going up or down should be the same, but moving it from left to right, that's not unique because the period keeps repeating itself over. There's many cycles in this one. All right, so I have the amplitude. So I'm going to say my function is supposed to look like this. It's supposed to be amplitude multiplied by sine, right? This is what I want. I want to kind of make it look like this. Then whatever it is compressed by, so whatever my period is compressed by, x minus h, okay, plus some k. So I want to find all of these. Now the easiest one to find is probably your amplitude. So that's first. We know that this is 3. So we have that. So that's great. Now the second thing that you can take a look at is, what is this d? What are you compressing the period by? Now in order to do that, my recommendation is to find just one cycle of your sine function. And it doesn't matter which one you pick. Just pick one particular cycle. So what I'm going to do is, let me remove this. I'm going to highlight for myself. Now you have to know kind of how sine looks like, right? So sine, if you remember, looks like this. It goes kind of like that, where it starts at 0, okay, within here. Yeah, so that's how it looks like. So that starts at 0, right? And if this was the axis like this would have been your original sine. Okay, so since we're dealing with degrees, your original period is 360. So this would have been sine of x, where you haven't done any compressions or stretches or anything like that. this would have been 180 degrees. This is 0 degrees, right? And this is your amplitude, which is 1 and minus 1. Now, we already know we've stretched it out. Our amplitude's gotten bigger. But now, okay, let's try to find one of these functions. One of these cycles. I'm going to pick, just for convenience, I guess, I'll pick this one. So this is going to be my sine, okay? My first cycle. From here, so from there to there. I'm going to zoom in on this, okay? Because I want to be able to see. Okay, so how long that is, right? Because everything else just keeps repeating to the left and then to the right. So that's my sine. We know the amplitude is 3 times bigger. Now, from here, okay, so this is going to be a little tricky because this point, right, so this middle point and then this middle point, it falls right in the middle there. And that would have been, okay, so this is right here, that's 50 and that's 40 degrees. So this is going to be 45 degrees. Okay, it's starting at 45 degrees. So it looks like there is some kind of a shift, right, that I'm going to have right there. So I shifted my original one, okay, to the right if I pick this one. Now the last one, so that point, where is that? If that's 150, this is 140, 130, so this is 135, okay? So that means how long is this? Okay, so it's from 135 degrees, so that one period is equal to 135 minus 45 degrees, which means this is 90 degrees. So the period is 90 degrees, okay? That's the period. So if you remember, okay, from right here, that's your period. Now we know that it is 90 degrees, so we can find that D now, okay, because period 90 degrees equals to 360 all over, okay, this D, okay. Now, D being positive or negative, notice that I'm picking the sign, which is like this, so it's not, okay, being reflected back in the X direction. So it's going to be positive. And now if I do this, if I solve for D here, 360 divided by 90 is just 4. So it looks like my D is going to be 4. So I have this, all right, so that's 3 sine, this is 4. Okay, now I'm still curious on what's happening there and then what's happening outside there. So far, so good, I hope. Now, okay, so now that I have that, now I can take a look at the shift. So, the shift of the sign, so notice I went in this direction so my starting point, so take your starting point of your sign, and where did it start? It started at 45 degrees, right? And it's to the right. So this is going to be minus 45 degrees, okay? Now, if you're doing it in radians, this would not change. This would not change, right? Because the amplitudes and the compressions don't change. The only thing is, this 45 degrees. So if you remember, so 45 degrees is pi over 4, okay? This would have been pi over 4, so minus pi over 4 if you had to do it in radians. But they're using degrees, so keep it 45. Now, my K, your K that you have is always going to be, so this one is one of the easier ones that you have. Your K is basically wherever your mid-range is, right? Where that midpoint is. So it looks like it got shifted down by -2. All right. So within here, so this is going to be, okay, got shifted down by -2. And that's for both in radians or in degrees, right? Because radians or degrees are only for the x-axis. So this is what we would have, okay? That's kind of how your function would look like, okay? And the restrictions that you have, I wrote, so your domain, you found your domain and then your range right there. So we have constructed now our function. So here it is. So f of x is equal to all of this junk. And that's how you can go about and do it. So it's not easy, you know, take a screenshot and then try to see if you can do it on your own. Now, again, it's not unique. It's not unique because, now why I say that is, if I picked, so now notice, so within here, you know, if I picked instead, you know, and I said, okay, my sign that I'm picking is going to be for one cycle is this, okay, then obviously this is being, you know, it has a different, okay, shift, and it would have got shifted to the left now. So it would have been like plus, okay, 45 degrees that you would have had. So in terms of like being shifted over. So that's why, you know, this right here is not unique. So maybe I'll highlight. This is not unique, this shift, because it depends on where you are, you know, starting your cycle. Okay, so that's not going to be unique at all. So be careful with that one. Okay, so let's take a look. Here's another example. This one, it says it's in radians. Okay, so if it's in rate, and I can see that it's kind of in, it might be in radians there because the x is a little bit smaller. Okay, so, I mean, I wish we had a little bit more here information because the edges, I don't really see the edges here that well, but we'll do the best we can. Not everything is always ideal. Okay, so we're basically kind of going, looks like, so here's our domain. So we're going to be starting kind of like there, and I guess, okay, we're going to go all the way up to, oops, it's moving my, so here it is, so it's something like that. Shift this over. Okay, so it's kind of like this from there to there. Now it's in radians. Okay, so we're going to try to figure out what that is. So in terms of the domain, let me go back. I like these questions because they, you know, they make you think. They're not perfect either. So I'm going to kind of gauge here. So let's see. Okay, so we have, so I'm just going to, you know, these, how is this divided? So this is 2. So that means this is 1, right? So that's a half. So it's going by halves, it looks like. So half, 1, 1.5, 2, 2.5, 3, okay, and so on. Okay. So that's the first thing. Okay, so I'm going to, all right, so if it's that, okay, so that means this is minus 0.5, minus 1, minus 1.5, and it's a little bit over negative 1.5, okay? Now, because it's in radians, so there's going to be pi involved for sure. So pi, so let's take a look. So what could that be? Actually, let's maybe take a look at one of the peaks. Yeah, well, that is the peak right here, right? And then it goes all the way down here, which I guess comes back to 0. Okay, so that's, so notice not that easy. Okay, so let me take out the calculator. Just going to play around here and see. So that's negative 1.5, a little bit more than negative 1.5. So that it looks like it's going to be pi over 2, right? So this looks like it's going to be pi over 2 negative, because the reason why I say that is because if it's, so notice pi divided by 2 is around 1.57, and if this is a little bit over, so it looks like it's, so it looks like this is negative pi over 2. This looks like it's 0. Right? So this right here, so this peak right here, this would have been pi over 2. And actually that makes, yeah, that makes sense, right? So that would have been pi over 2, okay, that you have in here. This would have been, I guess, pi. So that would have been pi somewhere there. Okay, so there we go. Okay, we're on track here. And therefore, so it ends, so if this is pi, this is going to be 3 pi over 2, I think. So 3 pi over 2. If it's going up. Okay, so this would have been 3 pi over 2. Okay, so let's take a look here. So 3 pi over 2. Well, no, this is over 4. Yeah, so let's check this. So 3 pi divided by 2, which is 4.7. Yep, so that looks right. So it looks like it's just adding by halves. Okay, so that means this is going to be 2 pi. Because plus a half. Okay, this is going to be, so plus another half. That's going to be 5 pi over 2. And therefore this is going to be 3 pi. Okay, because it's 6 pi over 2. So that's my domain. So that was a lot harder to figure out. So looks like it's from minus pi over 2 x. Again, this might be less than or equal. We can't really tell directly from there, but it's going to be like this. Okay, so let's see, we have that. My range. Okay, so what's my range here? And my range is, oh great. Okay, so 2, 4, that's 5. Sorry, 4, that's 3. This is 3.5. This looks like it's 3.5. That's the peak. Okay. And what does that mean? That these are halves. Half. And this is negative 1.5. Okay. So it goes from negative 1.5 to, sorry, what was that? To 3.5. Okay, so here's our mid-range. Looks like this is going to be cutting it off there. And by the way, let's write this one as a cos. All right, we're going to try to do this one as a cos. We did the other one as a sine, so now let's try to figure out this one as a cos. So we'll do that. So we have, so now next, okay, so that is mid-range, which is going to be 1. Okay, so this happens at 1. This is 1. So over here, that's 1. Which means my amplitude, well, I guess my amplitude is 2.5. That's what that looks like. So this looks like it's 2.5, right? So 3.5 plus... and then the 1.5, which is going to be 4 or 5, yeah, 2.5. So that's my amplitude, which is 2.5. Okay, great. Now compression. All right, so let's take a look. So now, since we're looking at cos, well, cos looks like this, right? It kind of goes like that. Well, I mean, I guess it, yeah, kind of looks like that, right? Where you're going in this direction. Okay, so that's my cos, right? That's one cycle of a cos. So if I look at this, this is going to be, so I guess I can do that. I can take this one. Okay, so that's one cycle, and then it looks like, okay, now it's repeating, but now it's obviously cut off there. Okay, so this is a great one. So that's one cos. Now, compressed. Okay, well, notice this goes from, so this is 3 pi over 2. All right. So that's from there, and then from, negative pi over 2. So what does that mean? It means we have 3 pi over 2 minus, negative pi over 2. So this becomes a plus, right? Plus. So that's going to be 2 pi. Okay, so that's what we have there. So that's 2 pi. So that's the period. So it looks like it's 2 pi, which means for us, okay, if that's 2 pi, then d is equal to 1. Okay, so d is going to be equal to 1 because you haven't compressed it at all. So, so you will have, so let me go back in here. So a, so we said we're going to use cos, d, okay, x minus or whatever, or plus, we don't know yet. Okay, and then we don't know the last one either. Okay, up or down. Well, no, we do know up or down already. That was 1. So we do know that we shifted it up by 1. Okay, so this one we know. Okay, so this plus k. So we know already this is 2.5 cos. D is 1. So I mean it's kind of redundant to write it. And this is, then this we said we moved it up by 1. So now the shift, and what did we shift this by here? Okay, so we shifted it over, so it looks like we shifted it over in this direction, which is by negative pi over 2. Okay, so by negative pi over 2. Okay, so remember, so h, so negative, so that means it's going to be positive pi over 2, okay, in radians. And there we have it. That's our function. You know what? Let me plot it, okay, within here. I want to plot it just so that I can show you. I'm going to try to split the screen. Let's plot it out. Let's kill these guys here, okay, and let's plot it. So what are we saying here? We have 2.5 cos. I'm not going to write that 1. So x plus pi. Notice you can write actually pi, pi, and it decimals converts that for you. So we have that plus 1. Okay, now we have it restricted. The domain is negative. Okay, so here we go. So negative pi over 2. Okay, less than, so x, and it was 3 pi. Okay. Let's take a look. So this is how it looks like. And there we have it. Now that's cool. Okay, so notice matches it up exactly. Perfect. Okay, so that's kind of how we had it there. So 8, 1, 2, 3. Yep. Okay, and it shifted it back up. Okay, so there it is. Now, if you had it written as sine, it would have looked different. But again, please remember that if you wanted to change it as sine, you can take the exact copy, and all you have to do and put in the brackets, because you're going now from cos to sine, you're gonna have to put another plus pi over 2, right? So that's what you would have had to do. So within here, so it would have been 2. If you wanted to write this as sine, for instance, you can take the entire same thing, so pi over 2. Now the only thing is that you have is, so that's from right here, right? Because how they're related, they're just related by a shift. So now you would have to add another pi over 2. Okay. And what was this? This stays the same. Notice they're right on top of each other. All right. So I guess, pi over 2 plus pi over 2 would have been pi. So that would have been just a shift. Okay, this is great. Guys, let me kill this and come back in here. So those are the 2 examples, okay, that we have. All right, so here's the last one. So let's try to knock this one off a little bit faster. I'm going to try to do both sine and cosine to map this out. All right, so let's take a look and see what it gives us. Again, for all of these, because of the translations back and forth, they're not unique. All right, so the answers are not unique. The amplitude should be unique. Your compression or stretch should be unique. All right, and your shift kind of up and down is unique, but your shift going left to right is not unique, because depending on where you assume, you're starting with your period. All right, so that's something you keep in mind. Okay, so I'm going to try to knock this off. So this one is all in degrees, so let's take a look. So we're going, looks like from here to here. So my domain, well, this one is much easier to pick off than the other one. Thank goodness. So it looks like we're restricted between 5 and 35. Okay, so that's 1. My range is between 1 and 5. So that's another one. Now, what else do we have? Now we're gonna, okay, so our midpoint actually is, our mid-range is very easy to pick off here. So this is kind of the midway. So that means here's our amplitude. So that's gonna be our amplitude A. So that's 2, right? 5 minus 3. So mid happens at 3. And now my amplitude is 2. Okay, so I can start filling this out. So this is going to be 2, let's keep it at sine, 2 sine, okay, something. I already said this was moved up by 3, so that's the mid range, which is your shift up. Now let's see. Well, this looks like it's a compression again, except I don't have a nice sine here, because, you know, the sines, they go like this. Okay, so what I'm going to do is, okay, so I'm going to extend this, right? So I'm going to take it kind of like this. I'm going to take that part. Now, I know, obviously, between 0 and 5, it's not part of my domain. But that's okay. I'm just trying to find the function. And then when I restrict it, it would remove that portion anyways. And actually, nicely enough, notice that the starting point is 0. So that means there's not going to be a shift left or right here. And so what that means, now actually the period itself is from 0 to 20. So period is 20. So that means this is 360 over my D, right? Well, D is going to be positive because it's nicely captured like that. And actually, I pretty much always pick the positive anyways. So that's another thing that, you know, you have to keep in mind. I guess for your D, you know, technically, if you start flipping, it depends. If you're not going to take the sine or the cosine as it is, like if you take the kind of flipped version of it in the x-axis, then, you know, you might have to worry about your D being negative. I always kind of pick it as positive, so I always pick that one. That's why it doesn't really change. So within here, so this is going to be D, so 360 divided by 20. So what is that, 36? It's going out of my head here. 18, sorry. Okay, so that's 18. And we have, so that's my D. So that's going to be 18. There is no shift, so I'm done. That's my function. And now, if you want to write this as a cos, then you literally, okay, so this is what you do. You copy it exactly, okay? You remove this because now you want it as a cos, right? Now, clearly these are not the same, so what you have to do now is, I'm going to shift this over a little bit. You have to take that, and because you're moving it to cos, it's going to be minus 90 degrees. If it's, is it in degrees? Yeah. If it was in radians, then it's pi over 2. And that's all that you do. Like literally, that's all you change. So no matter what you have in brackets there, you keep it in brackets, and then you just, you know, shift it over. So if in brackets, let's say if you had 5, you know, sine, I don't know, 3 and x, you know, minus 30, all right, something like that, you know, plus 8. Again, all you would do, okay, for this, you would duplicate it, and if you want to change it, so you change this, this would have been cos, and now all you do is you shift this over, and assuming this is in degrees, then you would have just changed it by that. Now you're gonna have to, you know, if you want to still keep it in this form of the transformations where it's a, cos, d, and so on, then in here, now you're going to have to simplify this, right? You would have to say, okay, so this is 3x minus 90 minus 90. Well, notice it's going to be actually 3x minus 180, right, in total. And now you can remove the 3, so it'll be x minus, this would have been 60. Okay, so, you know, you would have had that. Okay, but that's all that you actually do. And if you go from cos to sine, then instead of saying minus 90 in brackets here, you would have said plus 90, and you would do the same thing. So I hope that's kind of useful. You know, you can make a little note for yourself as well. But this is really it. Okay, if you can knock these off, then you're pretty good with these transformations and then going back and forth with the graphs. Okay, thanks for watching. See you in a future video. Cheers.